Make sure you get your graphing calculators out too, because you're going to depend on that. That's one of the things we're going to go over is how to find.
Drill team?
Yep, calculator drill team. This is so. I'm just going to do the small stuff. Well, hopefully y'all can see everything. Yeah, it should be presenting. So I'm trying to get everything.
The last day of class and then one Pendleton each other.
Pendleton did.
Only one of them.
Well, they communicate with each other. So the other two are caught in traffic for the ACC game. It's next Saturday, right? Yeah, they're caught in traffic.
Their fourth grandma.
Let's see. All right, calculator and whiteboard. Okay, now the first way to solve systems of equations is by graphing. Now I'm not even going to show you how to graph. You should know how to graph by hand. You should know how to graph. But the first way to solve systems of equations is to find the intersection of two lines. So I'm going to give you an example, and then you graph them on your graphing calculator and find the intersection. So 2x plus 4y is equal to 8, and 3x minus 2y is equal to 6. So the first thing you do in most of these questions, well, in graphing, you solve for y because that's the best way to put it in your calculator. So 2x plus 4y is equal to 8. 4y is equal to negative 2x plus 8. Divide by 4. Divide by 4. Divide by 4. Y is equal to negative 1/2 x plus what? 2. So that's one that you'll put in your graphing calculator. The other one, 3x, or I'm just going to go ahead and say negative 2y is equal to negative 3x plus 6. Divide by negative 2, divide by negative 2, divide by negative 2. Y is equal to 3/2 x minus 3. Now, punch those in your handy-dandy calculator. While you're punching it in yours, I'll punch it in mine.
Yay.
So y is equal, I'm going to make the first one dashed. And I'm going to type in negative, I'm going to be quick. Negative 0.5x. Now, the only reason I can use 0.5 here is because 1 divided by 2 is 0.5. If you have a repeating decimal, you need to put in the fraction and put it in parentheses. So it'd be parentheses, negative 1 over 2, close parentheses, then x. Okay? Plus 2. And then the next one, here I can't put in, well, I can put in 1.5 if I want to, but I'm not going to because I want to show you how you need to type it in. Parentheses, 3 divided by 2, close parentheses, x minus 3. And then hit graph. Now, we have an intersection. You can tell. So you go look for it. How do you look for it? You hit second, trace, intersect. second trace intersect. And I do not know how many of you know this, but that's how you do it. And then you don't have to hit the first or the second, just hit enter. Is this the first, is this the line? Yes. Is this the line? Yes. And then give it an estimate. Why do you give it an estimate? Because it narrows down the parameters for it to look for the intersection. It kind of speeds up the process. And there is your answer. Somebody write that down. 2.5, comma, 0.75. Now, there's three types of answers for solving systems of equations. Let's write this down. One, you get an answer just like we got, an intersection. 2.5, comma, 0.75. Everybody with me? Everybody understand that? What if you have parallel lines?
No intersection.
There's no intersection, therefore there's no solution. No intersection, because they're parallel, that means no solution. And the O with a line through it means no solution, but you can put no solution if you want to. 3. What if it's the same line? What if you have the same line? What if you get y is equal to 2x plus 6 and y is equal to 2x plus 6? All real numbers. And that's true if you get 5 is equal to 5, or right over here when we do elimination and substitution, 5 is equal to 5. That's a true statement. So all real numbers. What if you get 6 is equal to 21? Where is the... Whatever. What if you get 6 is equal to 21? That's not true. That's a contradiction. So your answer is no solution. And of course, the only solution that you get, 90% of the time, you're going to get a solution. Okay? So you need to write that down right there, because in this whole unit, and I put just one section of homework. And did anybody see it? Okay, what's it called? It's called Hubert's chapter something, unit, blah, 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 homework for the last test. I have to put for the last test on there because some of y'all will go, oh, I didn't know it was the last test. Okay, let me go ahead and tell everybody right now. There is a last test. It's on this material right here. We talked about it a week or two ago when I said there will be a last test. What does it say? Did you look at it?
I don't see it.
Huh?
I don't see it. Final exam. Yeah, I don't see it anymore. I see.
You saw it this morning, didn't you? Okay, okay, I'll look for it in a minute. I'll look for it after class. Anyway, this is your first, solving systems of equations, and that is by graphic. You'll get 2 or 3 problems on the test like this. The next time is substitution. 2x plus 4y is equal to 8. 3x minus 2y is equal to 6. I have no idea if that's what we just did or not. Is that what we just did? Yes?
Exactly.
Make sure it's the same one. All right, so I'm going to solve one of them for y. And I don't care which you do, it doesn't matter. So 2x plus 4y is equal to 8. 4y is equal to negative 2x plus 8. Divide by 4. Divide by 4. Y is equal to 1/2 x minus what? 2. Now what am I going to do if y is equal to negative 1/2 x minus 2?
Substitute it.
Plus 2. What am I going to do with that?
Substitute it.
I'm going to substitute. That's why it's called substitution. I'm going to substitute that into either one of these for y. Now I usually use the other one. So 3x minus 2, and I'm going to put this in blue because we're going to substitute this in right here. negative 1/2 x plus 2 is equal to 6. Now solve it. 3x. What's negative positive? Negative times negative is positive. And what's 2 times 1/2? 1. And what's negative 2 times positive 2? 3x plus x is 4x. Bring that negative over here, that's 10. Divided by 4. And what's x? X is equal to 5 over 2. Right? Is that what we got a while ago? Did we get on the previous?
Yeah, that's right.
Okay. So what do you do with x is equal to 5/2? Back substitute it into this. Y is equal to negative 1/2 parentheses, and I'm going to circle this red, and it goes right here, plus 2. Y is equal to negative 5/4 plus what? 8/4. Check my math. And negative plus 8, that's 3/4. Is that what we got?
Yes.
So y is equal to 3/4. So your answer, the intersection of these two lines, is 2.5, comma, 0.75. And it should be the same answer we got in the previous problem, if I wrote everything down right. So that's your second type question that's going to be on the test. Now, all of you should be saying, I've seen this before. Okay, the last one is the elimination method. So I'm just going to erase everything so I don't mess up the question that we were doing. Well, I just did. Oh, there we go. So go ahead and turn to another sheet of paper. And this is method 3. And it's called elimination. Now, elimination, you look for 3 things. Well, you try to do one of 3 things, or I'll just write them down. 1, look for opposite signs. 2, look for same equal coefficients. 3, if not 1 or 2, do it. In other words, if you don't have number 1 and number 2, you're going to have to manipulate it. So, do we have opposite signs anywhere?
Yeah.
Yes, right here. So I'm going to highlight these 2 right here because I'm going to get rid of the y's. Why? Because I have opposite signs. That makes the problem easier. Could you get rid of the x's if you want to? Yes, I'd have to multiply the top by negative 3 and the bottom by positive 2. Okay? You've done this before? You should have. Anybody that's had Algebra 1 or Algebra 2, Algebra 2, usually this is taught in Algebra 2. So, I'm going to multiply, now I got to get this. I've got this, now I've got to get this. Because I don't have the 4 and the 2 is not equal. Now, if they were equal, you wouldn't have to do anything. You just add them. But I'm going to multiply this by a 2. And now I'm going to rewrite the first one. 2x plus 4y is equal to 8. 2 times 3 is 6x. What's 2 times negative 2? Negative 4. And 2 times 6 is, what's the most common mistake done here.
People don't multiply the sets.
That's right. That's the most common mistake. People will go, oh, that's 6x minus 4y is equal to 6. And you'll get a crazy answer. So, I'm ready to add the two. So I take my handy dandy red marker, and I do this, and what happens to one of the terms? They should go out. And that leaves you with 6x, 8x is equal to what? 20, which divide by 8, x is equal to 20 over 8, which is 10 over what? 2? Somebody help me out. 10 over 4. Thank you. Huh? 5 over 2, which is equal to 2.5. And what do you do with that 2.5? Plug it back in to either one. I don't care which one. Two times 2.5 plus 4y is equal to 8. 2 times 2.5, what's 2 times 250? $5. Plus 4y is equal to 8. Minus 5, minus 5. 4y is equal to 3. Y is equal to 0.75. So there is 50% of your test. 1 elimination, 1 substitution, and 1 graphing. You'll have probably, let's see, there's four things that I'm going to test you on. So you probably, if I give you 20 questions, you're probably going to get 4 of each. Probably going to give you 10 questions because this does take a little bit of time. So probably give you like 10 questions. I can't remember how many I gave you. Okay, the last section is called partial fractions. Somebody look that up for me because we're not going to do, what section is that in the outline? I'm sorry, what?
7.8.
Thank you. I just covered 3 sections, but I don't want you to have to do the homework, so I just made a homework for you. I don't know why it happened. That's why I need to pull it up also. Pendleton, y'all seen these 3 things before, haven't you? Okay. Oconee, have you seen these 3 things before? Okay, Pendleton, I guess they just not awake. I don't have them muted. They muted themselves. They're not supposed to do that. How'd y'all mute yourselves? They're still muted. Hit the microphone. Hit the microphone.
Punch it.
Thank you. I still can't hear y'all. Look at the microphone on the table. On the table. Hit the button. It should turn green.
Oh, can you hear us now?
Yeah.
We were trying to do it on the screen.
Sometimes it doesn't work. You have to hit the microphone. Okay.
All right.
I just wanted to include y'all. That's all.
We had no idea.
That's all right. No big deal. Y'all just did it on purpose. I understand. All right. 110. I'm just going to pull up y'all should have the homework there. Assignments. Come on. And it's not there.
701, 7.8.
Well, there's your last test right there. But I don't understand why the homework's not there. Let me check out. Oh.
Is this homework you're talking about replacing 7.1 and 7.8? Or is
Yeah, I took chapter 7 off.
Oh, okay.
Well, okay. No, I didn't. Okay, I'm sorry. I took 7.5 off. There you go. 7.8 is right there. Okay, I'm wrong. Okay, but your Unit 4 test is right there. See it?
I see.
Okay, so don't act like y'all don't know there's a, and they're both due the 10th. Okay, so don't anybody call me up and say, oh, no. So the third musketeer, make sure y'all tell him because I don't.
I think he knows.
Okay, just want to make sure. All right.
Is that our final exam? Like, is that the one that we'll finish on, or are we taking another one after that?
Why would you take 2 final exams?
I didn't know if we had like an in-class final exam like we had to come to, because my other class we have to come in
Oh
for a
hell
final
no!
exam.
I don't do that stupid stuff. That's some
All right.
departmental. That's some departmental rule. Oh God, no! I don't do that.
What's the last day of class?
I have no idea.
Today.
I know you're kidding when you ask that, but you know I'm not gonna answer it. All right, let's go to.
Allele.
Yeah, I'm gonna take attendance on the last day of class. Yeah. Yeah, tell her I'm gonna make sure I take attendance. I haven't been taking attendance the last 2 weeks.
She's still on her way.
Okay. Well,
I've
that's
been
good.
getting an email that says,
All right, I can't find.
there we go.
It happened in one day. I was like,
Exactly. I didn't come up.
I don't fill out the last 2 weeks of class. If you've made it 12 weeks of attendance, you think I'm going to worry about the last 2 weeks of attendance? No. All right, what'd y'all say? 7.8.
yes.
Yeah, I know. I do too.
All right. Now, some of you may have seen this before, and the only reason I'm showing you this, you will see it again. So you better mark it in your notebooks. You will see it again in calculus. Okay. So let's go ahead and hit slideshow, present, primary, and current slide.
Have to find the.
Okay. This is when you're given something funky. Well, if I could work the frickin' there. All right. This is when you're given something funky. What do I mean something funky? Well, you're given something that looks like that. Okay? Now, when you're given f of x is equal to 2x over x squared minus 1, there's nothing you can do. You can't factor out an x. Like, let me show you an example. Where did my whiteboard go? It just disappeared. I don't understand what happened to it. I guess it just said heck with you. I don't really care. Now let's try it.
3, 2, 1.
There.
You have a work email.
All right, sometimes you're given this. F of x is equal to x over 2x minus x. And you can factor out x and get x times 2 minus 1 or whatever. Cancel out. All right, you're given something. You can work with some of these. But this one, you can't work with this one. Why? Because this is 2x over x squared minus 1. So you can't factor out an x down here. So what do? You got to use partial fractions. Okay? Partial fractions is when you break up everything and you set equal to ax squared plus bx plus c is equal to 0. Anyway, let me go on and show you. Okay? Like this, for instance. they're showing you verifying a partial fraction. This is not really what I want. They're showing you how to do it. I don't really care about this. That's great. Great. They're showing you how to derive it. I don't really care about that. Come on. Good. That's good. Yes, hallelujah. That's okay, here we go. All right. For each different model, you're going to be given a template. Now, if you just have 2x over x squared minus 1, or whatever the case may be, if you have that, then you're going to use this. Okay? A over ax squared plus b, or ax plus b. If you're given a more complicated one, you're going to use those. Bx plus c over cx squared plus dx plus e. So you've got this one to start off with, a over ax plus b. And then you've got this one, bx plus c over cx squared plus dx plus e. It'll all fall together when I show you how to do it, okay? This is just a lot of theory. And then, okay, they're going to go ahead and show you how to do it. Find the decomposition of negative x over x plus 1 over x plus 2. Now see, you can't factor anything out. You can't cancel anything. So all you can do is sit there and stare at it. If you ever have one that you just sit there and stare at it, what do? The numerator has a degree of 1. Okay, that's good. Okay, good. Here we go. Thank you. Now, this is what you need to write down. If you have one that looks like this, do you see any quadratics down here? Do you see an x squared plus 2x plus 3? No. It's just two separate entities right here. Everybody see that? If you have that, then you set it up equal to a over x plus 1 plus b over x plus 2. What if I had an x minus 3 down there? Then you put c over x minus 3. Everybody see what I'm doing?
Yes.
Okay. So, if this had an x minus 3 down here, I would have plus c over x minus 3. Okay? Now what do? Well, we're going to multiply both sides by the common denominator because you want to get rid of the fraction, right? So, multiply both sides by x plus 1 times x plus 2. Go ahead and do that. Multiply both sides by x plus 1 times x plus 2. There. Now, what naturally happens? Well, on the right and the left side, everything's going to cancel except for the x. And what cancels over here?
The x plus 1.
And what cancels here?
X plus 2.
All right, now rewrite the equation. It's going to be negative x is equal to a times x plus 2 plus b times x plus 1. So all we're doing is using algebra. See, there it is. Now, this equation is identity and must be true for all values. If we let x is equal to negative 1, we can easily determine a. Okay? So if I plug in negative 1, then I can do 0, but there is no such thing as negative 0, is there? And the best number to use besides 0 is 1. And you can use 2 and 3 and 4, but you're going to find out the equation. So just go with 0 or what? 1. And then if 0 or 1 don't work, then you go with 2. You don't go with 5,422 or negative 0.67. You don't do that. You either pick 0, 1, or 2. They're picking negative 1. They're picking negative 1, and then they might pick 0 because you can't have a negative 0. They probably won't pick 0. and negative and positive 1, you could do that. But they're picking negative 1, okay? And the reason they're picking negative 1, I think, let's see, go back one. Oops. Yeah. What does negative 1 give you right here?
0.
There, and they're going to pick negative 2 right here. So your answers are going to be negative 1 and negative 2. You're going to use those two numbers. Why? Because negative 1, for those of you that's not in, negative 1 will give you a 0 there, and negative 2 will give you a 0 there. And that's what you're doing with partial fractions. You're zeroing out one term so you can solve for the what? For the other. So if you plug in negative 1, what do you get? Well, that negative 1, that goes out. So take our red marker, and it's kind of like the elimination method. You know, in the elimination method, you get rid of a term. Well, we just got rid of a term. And now you've got negative 1 is equal to A1. So A is equal to what? A is equal to 1. Write that down. A is equal to 1. Then we're going to plug in a negative 2. There's the negative 2. And when you plug in negative 2, what happens to the A function? The A variable. It goes out. So B is equal to negative what? Nope. Negative 2. So it goes sides by negative 1. And B is equal to negative 2. Now that we got A and B, what do? Plug and shove. So this is your answer. Now hopefully they're going to give us an example here. All right, now this one is got all the cubes in it. All right, this one has the cubes in it, and you're going to have to use a different formula. There's going to be one or two. Either you use the first one or this one. And you're going to break it up. Now what did we do here? Using long what? Division. So we got to do long division, and we've already covered that. So x cubed minus 4x, well that's x, we're going to have to go back. Let me go back right here, and I'm going to have to do it, and I'll have to erase it. X cubed minus 0x squared plus or minus 4x, that's 3, 2, 1, plus 0x, plus 0x to the 0, there we go, into 2x to the 4th plus 0x cubed minus 8x squared plus 5x minus 2x to the 0. So are all place values accounted for? Yes. So now we can do long division. And we've already talked about this, so don't come up here and say, oh, I don't know what you're talking about. Okay, we've already done this. So how many times will x cubed go into 2x to the 4th? 2x to the 1st. What's 2 times 1? 2. What's x to the 1st times x to the 3rd? X to the 4th. What's 2 times negative 0? Negative 0. What's x to the 1st times x squared? X to the 3rd. What's 2 times negative 4? Negative 8. What's x to the 1st times x to the 1st? X squared. What's 2 times 0? 0. What's x to the 1st times x to the 0? X to the 1st. What do we always do? You always subtract. So I'm going to take my negative and I'm going to distribute my negative. There, there, let's say that'd be a positive, and that would be a negative, which it doesn't matter, but you just got to get in the habit of doing it. And what always happens to the first column? Goes like, so we get 0x to the third. What happens here? That goes out. That goes out. So what's the only thing left? 5x, and this comes down to help out. So that's the remainder. So I've got, my answer is 2x plus, let me get rid of that right there before you go. There we go. 2x plus what? 5x minus 2 over what? X cubed minus 4x? Is that right?
Yes.
X cubed minus 4x. I think that's what they should get. Two x plus 5x minus 2 over x cubed minus 4x. Everybody with me?
Yes.
And everybody should remember how to do long division. So now we've got 5x minus 2, and we've used a little bit of algebra, factor this out. If you factor this out, you get x, and that's going to be x squared minus what? 4, and that's shortcut number 2, x times x plus 2 times what? And that's how they get that. And now we've got this. Now multiply everything by x times x plus 2 times x minus 2 on both sides. Go ahead and do that. I'm going to multiply. I'm going to take my blue marker, and I'm going to multiply this and this by x times x plus 2 times what? X minus 2. And I'm just going to write it across here. X times x plus 2 times x minus 2. And of course, what happens on the left-hand side? All that goes out. So what is on the left-hand side of the equal sign? 5x minus 2, Hubert. So somebody tell me what's over here. What cancels here?
X.
So that leaves a times x plus 2 times what? Plus b times what? X times
X minus 2.
Golly, y'all catching on. Y'all not supposed to do that. Y'all supposed to be lost and clueless.
Okay, I can do
C times what? X times x plus 2.
I don't like that at all.
Well, it's real simple because what numbers are you going to use now?
0.
You're going to use 0. What else makes a 0? A positive 2 and a.
Negative.
So you're going to use 3 numbers here. So x is equal to 0. I'm going to use green here. I'm going to show you where I get those numbers from. What will make this term go to 0? X being 0. What will make this term go to 0? What will make this term go to 0? So there's your 3 numbers right there that you're going to equal x equal to. So go ahead and do that. It's going to take you a couple of minutes to do that because you got to do it like 3 times. So go ahead and be working on that. I'm going to set the first one 0, so that means 5 times 0 minus 2 is equal to, well, the 2 with the x's, what are they going to do if you plug in x is equal to 0? What's b and c going to do? I'm wanting interaction there. Say it a little bit louder. Impress me.
Go away.
There you go. Go away. They will. The b and the c, when you plug in 0 for x, they're going to go away.
Right.
So, I'm going to plug in my 0 for x. I'm going to start with 0. And I'm not going to do the algebra because I think y'all understand that if I plug in a 0 here and a 0 here, what's going to happen to these two terms? They're going to go out. So that just leaves me
You have a work
with
email.
0 here, and a 0 here, and a 0 here. Everybody with me? I'm trying not to write because I want to save as much space as possible. Minus 2 is equal to A times x plus 2, x minus 2. All right, what's 5 times 0 minus 2? Negative 2. A times 2 times negative 2. Negative 2 is equal to 4A. And what's negative 2 divided by negative 4? So A is equal to what?
1/2.
So put that over here to the side. Now you got to erase all this stuff and start over with positive 2. So I'm going to erase it. Let everybody look at it for a couple of seconds. Okay? And now I'm going to erase the 0. And since we read from left to right, I'm going to do negative 2 first. So now I'm going to take another color. Let's use magenta. And I'm going to plug in a negative 2 right there and a negative 2 right here. And what will that do to these two terms? It will destroy them. It'll blow them up. It'll cause 0 terms. So I'm going to be finding what? B, aren't I?
Yes, you are.
Negative 2, thank you. And negative 2 minus 2 is equal to 5 times negative 2 minus 2. All right, crank that out.
B equals 2.
Now the reason I only have the B is because negative 2 will make that 0, and negative 2 right here will make that 0. So A and C go out. So what is 5 times negative 2? That's negative 10. Minus 2 is negative what?
12.
Negative 12. And negative 2 times 2, negative 2 is, or I'm sorry, negative 2 minus negative 2 is negative 4. Negative 4 times negative 2 is what?
8.
And divide both sides by 8. So B is equal to what?
Negative 3 over 2.
Thank you. You're supposed to mumble and whisper. All right, now I want y'all to do 2. Somebody tell me, if I plug in 2, what terms will cancel?
A and B.
A and B will cancel. Good.
Yay.
So do that. Quit saying that. That's getting on my nerves. You're having me start saying it all day.
Yay.
So I'm going to use, I don't like to use red, so I'm going to use, let's use that aqua color. So if I plug in a 2 here, and I plug in a 2 here, and a 2 here, the terms that are going to go out is going to be the A term and the what? The B term. Because 2 minus 2 is what? 0, and that 0 will knock everything out. So I'm going to be left with 2 and 2, 2, 5, 5 times 2 minus 2 is equal to, that goes to 0, plus 0, and then plus C times 2 plus 2. And that's going to give me 10 minus 2 is 8. That goes out, that goes out. You're left with C. What's 2 times 4?
8.
So C is going to be equal to 1. And C, we'll do that in blue. C is equal to 1. And what are we going to do with those three numbers?
Plug them into the thing at the top.
Right up here. So I'm going to take my blue marker and I'm going to put a 1/2 here. Okay? And I'm going to put a -3/2 here and a 1 here. Now, you can work with this. When you divide 1/2 by a fraction, what do you multiply by? 1 over x. So that's going to be 1 over 2x plus, well, that's over 1, so 1 over x plus 2, so that's going to be -3 over 2 times x plus 2 plus 1 over x minus 2. That should be your answer. Now you say, well, I'm just giving y'all like 10 problems on the test. I guess let's see if they got what I got. Is that what I got?
Yes.
I think it is. Yeah, 3/2. Yep.
Okay.
Oh no.
I'm not going to ask you to do
What
that.
is that?
That's doing it on the calculator. Okay, now, what's wrong with this one? This one is different. Why? It's raised to the what power? It's raised to the second or the third power. So you got something totally different here. Got 7 minutes, but I can fit this in. Okay? So, what do you do here? Well, you got to use that other. You got to use this one. So make sure you write that one down. If you've got something raised to the 5th power, then I'd have to do A plus B plus C plus D plus what? E. If it's raised to the 5th power, because you have to do X, you have to do X minus 1 to the what power? 1. X minus 1 to the what? 2nd power. X minus 1 to the what? 3rd power. Now multiply through by the common denominator. The common denominator is x minus 1 to the what? 3rd power.
And then, thanks.
X minus 1 to the 3rd power. And what happens on the left-hand side? I'll do that side for you. You get 2x.
C dies.
Now, what happens at x minus 1 and x minus, you get x minus 1 to the what? 2nd power. Equals a times x minus 1 to the 2nd power. What happens to b? b times what? X minus 1, and then what happens to c?
It goes away.
It goes to c, the ax minus 1 to the 3rd goes away, and you're left with plus c. So that's what you're left with there. Now, the good thing about this is, what number am I going to use?
1.
1.
Oh, this is going to be hard.
Huh?
Oh, this was going to be hard.
Well, it's just different. So I'm going to go ahead and get us to there. There you go. And now, we see that we got to use 1. And let's see what happens when I use 1. All I can find is what?
C.
C. Well, what the heck I'm supposed to do now? Well, you got to remember ax squared plus bx plus c. So anyway, let's go ahead and say 2 times 1 is equal to a 1 minus 1 plus b 1 minus 1, and of course those go out, plus c. So c is equal to what? 2. Go over here and you say c is equal to 2, and then you just sit there and stare at it. because we don't want to do anything. We don't want to raise the what? So we just sit there and look at it and just settle with status what? And we could put C is equal to 2, cannot find the rest. That's what you need to write on the
It's
test.
a big question.
Oh, right. I'm sorry, I forgot. We don't write.
Writing is.
There's, now, here we go. Since any number can be substituted for x, choose x is equal to -1. Oh, we just did that.
-1. It's -1
Why did they do -1?
because it doesn't kill it.
Well, yeah, but I think they're going with the old adage, -1, 0, and 1. So you could do that, but that's still not going to help us because you still got, I think, let's see what they're going to do here. -1, they plug in -1 from this adage right here. What's the 3 easiest numbers to work with? -1, 0, and what?
1.
So that's where they're coming up with that. -1 will give us C is equal to 2. Okay, they just already did that right there. Okay? Since any number can be substituted for x, we choose the next easiest number, which is -1. And they did that, and they get this, which is not really going to help us, but I thought they were going to use the quadratic equation. I thought they were. So, and then substitute in 0. Now, okay, you can do this. Plug in 0 and 1, and then use solve systems of what? Solve systems of equations. Systems of equations give us those two, and of course we can solve those two because, okay, where's the other one? There's another one somewhere. Where is it? Okay, did they solve?
We already know what C is.
Why did they do this? That's supposed to be A minus B is equal to -2. Why did they? That irritates me when they do that. Let me go back. Okay, when you plugged in right here, you see that one? That's when you plugged in -1. Everybody write that down. All right, -2 equals 2A minus B. Everybody got that? All right, now when you plug in 0, because those are the 3 easiest numbers, when you plug in 0, you get
The top.
you get the top one right here, which is equal to -B, and now you solve those two. If I'm looking at them correct, what was the other one over there? Wasn't it -B, -2?
-2 equals 2A minus B.
I don't understand what they're doing right here. Oh, they're dividing through by negative is what they're doing. So 2, okay, here's 1. And then what's the other one that I told you to write down?
-2 equals 2A minus B.
Okay, that's from the previous page. This is from the previous page. Previous at x equals -1. Everybody with me? And this is A at x is equal to 0. All right, now, which one goes out with elimination without even doing anything?
B.
B. So take those out.
And 2 also.
And what's -1 plus 2? -1 plus 2. I'm adding these two together. 1A is equal to what?
0.
So A is equal to what?
0.
A is equal to 0, and C is equal to what?
1. 2. 2.
What was it?
2.
Okay, so we still got those. And now you take that, and that's where you should plug in. I don't know what they're going to do next. Okay, did we get C is equal to, now solve the two equations with unknowns and get A and B. A is equal to 0. We got that. Oh, we got plug in A back in. Plug A back in and you get 2 and then you're done. I'm sorry. Plug A is equal to 0 back in. Plug A back into this one. What is 0 for A? What does that do? B is equal to what?
2.
2. And then you plug those in. And I'm going to show you this one last one. Okay, this one is a little bit different because you've got x plus 1 to the first power, and then you got something different. So what do you do on this one? You use this. And the reason you use this is because you have a quadratic up top. And then, and I'm going to just show you right quick, I realize, what time is it? Yeah, of course it's 10. We only got 5 minutes in this freaking class. Oh, maybe one day they'll change back to Monday, Wednesday, and Friday. Okay, let me just show you this right quick so you'll have it. This is the last one. Okay? Multiply both sides by the common denominator, and you get this. And that's where, I just forget it. I'll just cut the test off at the first two. I'm not going to go try to squeeze it in. All right, it's been a pleasure. You're chewing gums on the floor. Y'all get the last test done, and I'll cut off a little bit of 7.8 to just the two that we covered before. I'll do that next. And y'all have a good break. And a Merry Christmas. And a Happy New Year.
So this is the last class.
Thank you, Hubert. Thank you.
See y'all.
So we don't.
Thank you,
We don't.
Hubert.
We don't come anymore. Is today the last day of this class?
Y'all have a good break.